we will talk about injector head. So let's start. Injector head consists of many things, and it is the most revolutionary invention of coiled, in my opinion. In this section, we can see all of these components, and gooseneck in this part was hidden, which is this one. So it consists of loading cylinders or traction pressure cylinders, and here we can see two hydraulic motors. These two hydraulic motors connected to driving sprockets. These driving sprockets drive these idle sprockets. So these two called idle sprockets, and these two called driving sprockets. Hydraulic motors, rotating sprocket, driving sprockets in in reverse directions. So this sprocket will drive in this direction clockwise, and this in anti-clockwise. This in case of running hole coil tube. In blowout of hole, the reverse, this sprocket will rotate anti-clockwise, and this will rotate clockwise. When this rotates, it rotates a chain in yellow color. This chain is connected to this idle sprocket, so it rotates it with its rotation. It also connects to grabber blocks in gray color, and it has rollers in red color. Also, these traction cylinders connected to or pushing against this skate bar or inside the skate bar. So the cycle as follows. The traction cylinder pushes against inside skate or skate bar. The skate bar pushes rollers, and rollers pushes a chain which is connected to grabber blocks, and the grabber blocks is connected to coil tube itself. So this is about hydraulic motors, sprockets, chain, and traction cylinders. We have here a chain tension cylinder which pushes this sprocket to make the chain always in tension and prevent chain buckling in case of high pressure well. Also, we have load cells which reads weight measurement of coil tube. It can read compression or tension, or both. We will talk about everything in next slide. Here we can see sprockets. As you see, here is sprocket and sprocket. These are the driving sprocket connected to hydraulic motors. The red one, this red one is a hydraulic motor, and also this one. When rotates by hydraulic pressure, it rotates the shaft connected to these chains. Okay, so this is sprockets from above, grabber blocks surrounding the coil tube, and as it rotates with the chain, it injects or pulls the coil tube in or out of the well. This is single grabber blocks. The chain has grabber blocks along its length. So as you can see from here, all of this is grabber blocks. All of this gray color is grabber blocks. And this is only one grabber block. You have one above, one below, and so on, until you have the complete cycle of chain. The grabber blocks, as you can see, has gripping action due to this shape and this structure. This is schematic view of grabber blocks with a chain. These are the rollers, as we say. The rollers to allow the chain to move against skate bar. Imagine if these rollers are not there, the traction cylinder will push the skate bar, and skate bar will push directly against the chain. So there will be a great friction between them. So this is the chain, roller, and the grabber blocks. We have two types of grabber blocks: semicircular block and variable diameter block. Semicircular block is made for only one size of coil tube, for example 1.5. It has a stress distributed around the circumference of coil tube, so forces are less. In variable diameter block, the contact points are 2 points, so forces are higher, and the advantage is it's suited for many sizes of coil tube. It has a range of sizes of coil tube. This is the final picture of a chain with gripper blocks. The traction pressure, as we said, it pushes against skid bar, and skid bar pushes against rollers, and then chain with gripper blocks, finally at coil tube. It's called inside traction or traction pressure. Outside traction or chain tension is made from these cylinders pushing against only idle sprockets to make this chain in tension, always in tension. These are, as you can see, piston, this is stainless part, and cylinder, and hydraulic pressure from this hose inside this pushes against piston, so it pushes idle sprockets, this one and this one, keeps that to keep the chain always in tension. Weight measurement is made by many methods. It can be hydraulically or electrically. For hydraulic one, to measure both tension and compression, you must have two load cells, pipe heavy and pipe light, and of course pivot point. This pivot point makes the injector rest with its weight on these two load cells. So one will measure the tension and the other one will measure compression. As you can see from here, this is a compression load cell and tension load cell with fulcrum point here. So your injector in cyan color will rest on this load cell and this load cell. So if our system is hydraulically measuring weight, we can have two load cell, one for tension and one for compression. And this is the image of hydraulic load cell. We have piston here pushing against diaphragm, and this diaphragm pushing against hydraulic coil pressurized in this hose up to this weight indicator. So the injector weight rests on this flat surface, pushing against diaphragm, the diaphragm pushing or compressing oil. Compressed oil goes through this hose to read in this weight indicator. It can be, as we said, tension or compression. For electric load cell, we have strain gauges here. Here we have strain gauges. As this load cell deforms, the strain gauges shape changes, so the resistance and electrical properties changes. And this is measured by this electric cable at cabin. So this is two types of load cell, hydraulic and electric. We can see here depth counter. This is a mechanical depth counter, and this is depth encoder to represent this value in control cabin electrically in data acquisition system. So this data is recorded and interpreted. Please note that we have also a second mechanical depth counter on level 1 on reel, and usually we observe the depth from this one on reel, not this one, because this one is far from the operator, unlike the depth counter on the reel. Finally, about injector, we say to the gooseneck is the final part of injector. We talked about this part: traction cylinder, chain tension, skate, gripper blocks, and finally we talk about gooseneck, this part. Another view is this part. As you can see, coil tube is a black one. It goes around the gooseneck, so it is bended in specific diameter, so bending stresses are not high. Also, it moves around rollers. As you see, these are rollers reduces stresses and friction between gooseneck and coil tube. This is the shape of roller for different sizes of coil tube. This is gooseneck in retracted position. If you want to expand it, you push hydraulic oil in this piston from cabin or whatever. You push hydraulic oil from there, it pushes this part, so it's erected as this. The radius of curvature of gooseneck is determined by API recommendations. So for a given tubing size, we have a range of gooseneck radius, as you can see from this slide. So now you may have deducted the functions of injector head. It measures weight of coil tube injected or pulled from the well. So this first one. Secondly, it inject or pull coil tube using injector head motors, sprockets, chain, traction pressure, chain tension, all of this incorporated to inject or pull coil tube. It also holds coil tube in place by gripping action of gripper blocks. So this is the main function